G'day, welcome back to BuildSim, and what I want to show you today in this video is the strength and weakness of concrete and steel and how we use them together as reinforced concrete to provide or to form a very strong structural member of our building. So essentially this is our slab of concrete, and concrete is very strong when it's compressed or pushed together. So think about a force being pushed along the line of these arrows, pushing the concrete together. The concrete's going to stand up pretty well. It's not going to want to crack or anything, and it's very strong in compression. However, if we were to reverse the situation and try and pull the concrete apart, then the concrete's going to break reasonably easy. So concrete is very strong in compression, very weak in tension. Steel, like our reinforcing rod, however, is the opposite. It is incredibly strong in tension. So think about a tug of war with a steel rod. Even if you tied two cars to the rod, you'd need a fair bit of force to cause any damage to the rod. So steel is very strong in tension. However, if we were to try and compress it, it would very quickly deform and buckle and get out of shape. So steel has the exact opposite properties as our concrete. So that's why we can form them together. But the thing is, our concrete slab's just sitting there. How is it ever going to be placed under compression or tension? So what happens, especially with suspended slabs, if the slab's supported on both ends, such as this one, and then there's a load placed in the middle, and that could be the self-weight of the concrete or any live loads or dead loads that you're going to put on top of it, then what is effectively what's trying to happen is that the slab is being pushed or trying to be pushed into that shape. So what that does is, because it's now a concave shape, the top of the slab has actually been compressed by the load, and the bottom half of the slab is now in tension because it's actually been made longer. So this is where the structural engineers come into play, and this is how they work out where they're going to place their reinforcement. So we need to place reinforcement in the areas of the slab that are going to be placed under tension. So in this case, the bottom half of the slab is going to be in tension, so we need to put our reinforcement in the bottom half of the slab. Alright, not right on the bottom because we have to allow for our cover, and not right to the ends again for cover, but in the bottom half of the slab. Now, as I said before, this is where structural engineers make their money, because there's going to be lots of different situations where we're going to have different loads and different scenarios. So in this instance, such as a cantilever, we've got a load down in the middle, and again we're going to have the self-weight of the slab plus anything else we're going to put out here on this end of the slab, causing a load out here. So there's actually going to be a bend over that support and a bend in here as well. So this is where our structural engineers can advise us where to place our steel and what size it needs to be. So hopefully that shows you the relationship between the concrete and the reinforcement in a reinforced concrete member, and that we are using the best properties of both materials to form a highly efficient and a very popular building component.